Hi, my name is Pavel. I'm working here as a mobile core developer for iOS. And today I will be talking about building a design system in SwiftUI, or how we approach building a design system. As we have a design system in Kiwi, which is used for even the desktop on both mobile platforms, such as Android and iOS. But I will be now talking about the iOS part, because some of you may have already heard the part of the Android, so you will see some similarities there. And you might probably see some similarities from the previous talk about SwiftUI, mainly some pain points and things like that. So the goal of the talk is to show you how you could use this design system that we have in your project, because this is an open source project, so you can use it in your own app or web. But also I will be talking about how we implemented it, so this talk will have two major parts. But before that, let me just recap what the design system is. Well, this is something that you would either do or a designer would do for you. It's a library of some visual rules, also with a bunch of components that you would use, which is kind of limiting you when you are developing. But on the other hand, it gives you building blocks as if you would get the Lego set and just build from those Lego pieces. So you can't screw up so much as if you would do everything manually. So we have such design system in our app. We use it for most of the screens. And that gives the developers the power to build screens and some components with much more ease. And at worst, they can say that we screwed up, and they can just build it, just layout in the vertical stack most of the time. And the one power is that it's abstracting all the details. So all those components, all that foundation which is there, is hiding the design internal things that is kind of like a black box, and you can just easily use the component, hopefully using the simple API, which is what was our goal to do. And a small recap about the SwiftUI. It's an Apple UI framework, a successor to older UI kit, which was using imperative kind of way to tell what you want to see, which is obviously not ideal, because this is very different from what you will get from designers. And finally, this is a step from Apple to create a declarative approach to do UI, which means that when I hope you will see, well, this is kind of a side test for the last row. If you can see some of that code at the last row, great for you. If you don't, just trust me, there is a very beautiful, beautiful Swift code somewhere in there. And what it says is that on the left side, we can see the SwiftUI code, which declaratively says what we want to achieve in the UI, rather than how we want to do that exactly. And on the right side is a preview that in the tool that we use, which is Xcode, we directly see it next to each other. So again, if, for example, we click on something on the preview, we can have highlighted code on the left side. On the other, this is bidirectional, so on the other hand, when we highlight something on the left side, which probably is not seen because the projector either sucks or is calibrated incorrectly, then we will get the highlight on the right side, which is much better that directly when we implement stuff, it's even possible that not directly programmer could build these screens. It doesn't have to be fluent in Combine or all sorts of stuff. He could translate things from a designer's tool, such as Figma, which is very similar because this also can have stacks and some basic building blocks. So this is a great way to create UI on the Apple right now, I would say, in most cases where we can. And we were able to replace all the new screens for now with this technology, as it makes it much more easier and faster to develop and fix things. Our design system is called Orbit. You can find it on this website, orbit.kiwi. It's an open source project and can be used for any travel-like application or website. So you can directly take it and build some application, and you get it all for free. And it's also a good source of some tips and UI, UX best practices. So if you browse through that page, highly recommend. Just to show you how it looks like in the wild, I will show you 3 small examples so that you know how things look like. The first one would be obviously our kiwi.com application. And that's on the left side, where you cannot see, but you would see that most of the time, it just uses those building blocks to power the whole screens. It's just built from those design system elements. Then I will have some simple app through the talk, which I would just demonstrate how to use this Orbit library yourself. And the third one, parallel. Third one would be about, sorry for that, I will try to run just this one, maybe, no. Sweet. One more try. So if you are able with your brain to comprehend all three, just concentrate on the right side, which just shows that in the library you have some kind of storybook, they call it, which showcases all the things you have there. So you can just start the application and see all those components immediately, how they look like in those variations and combinations. This will be just a short demo of how in SwiftUI it's even the system guides you to use the composition to build bigger components out of smaller ones. The demo here is a component which the whole thing you see is a single component. Even the scrollable part is a single component which you provide some array of data, and it renders itself based on that. But if you would do such thing from the start, it could be overwhelming. So it's much better to slice the user interface to separate subcomponents, and I will show you later how we approach it. But the gist of that is that composition is the key in SwiftUI. Whatever you can extract to subcomponent, do it. It will save you time later, because each subcomponent has its own previews, and you will work on it in isolation. And you will have, as I will later tell, each will have its own snapshot and so on. The implementation of our SwiftUI Orbit version is in the GitHub. It's a public repo, and it sits there next to the React for the desktop and Jetpack Compose implementation for the Android, and it's distributed as a Swift package, obviously requiring iOS 13. So we had some trouble doing some components in a way that they are compatible with all those versions. Also, the repo is obviously work in progress still. There are missing components, there are bugs, so it can be a good opportunity to improve your SwiftUI skills by contributing on this repo. And now, what does this design system library consist of if you would download it and use it in your project? First major part of the design system is always some foundation. These are crude base building blocks for everything else. These are things like colors, tokens, illustration, resources, icons, even things like layout systems, spacing, sizes, and so on. So this is everything that further part will reuse. And that further part is just the list of those components. So in our design system, we have maybe 40, 50, I'm not sure, number of components, starting from very similar components like a badge, which just takes a string and an icon, let's say, where it's a simple stack, taken almost from the design itself. But it could go through some wrapping components that are more complicated, up to very much different components that take inputs and so on, and must behave correctly in various situations when you use them on a model screen or whatever else, such as those overlays, which is something like a dialog on top of the screen. And if you open the package, obviously you can just open it in the Xcode, just like that, the package itself. It's good enough for previews, but you would miss some correct transitions, you wouldn't see the software keyboard, and you can run it on the simulator. So you could do what I did here to just create a simple application which just imports this library, and you are all set up. So the content of this package is, as I said, most of the basic is the foundation, which has all those color tokens and illustrations and so on as the resources, which we synchronize with the Orbit backend kind of, so that we are always up to date. We define some of those constants so that it's very easy to use in the SwiftUI without any more boilerplate. And then there is the folder which hosts all the components, each component having its own file and its own previews. With all those variations provided by designers and also by us, because there are a lot of edge cases that designers might not have covered. So that's the content of this package. And now, just shortly about how to use this package in a very simple demo application. So again, on the left side, we have some code in SwiftUI. You see that it's obviously you can mix SwiftUI components with our design system anyhow you would like to. But the problem could be that our components sometimes have exactly the same name as the whatever is in the SwiftUI, the native components. But assuming that you would like to use this design system, it's a high chance that you want to use this Orbit version. So what we do is we shadow the SwiftUI version by using some aliases that are optional. So at the end, the programmer would just put things like that and build whatever you can see on the right side. So, which I will show quickly in the next animation. So that's basically the same screen, the more interactive. So you can see that we just imported the Orbit, and now we have a definition of some of those parts in the screen, and components such as alert or input field. These are our names for components, but we do have a component called button, and if you would like to use the SwiftUI button, then you just have to use the prefix, and that's it. So you can freely use this library without any clashes, I would say. And each component has a kind of helpful section how to use it. And now when we try to create or include a batch component here, we wanted the API to be as much simple as possible, meaning that obviously as the SwiftUI, most of the parameters have some sensible default value, but if not, we heavily use the enumerations to guide you through offering you what you would probably want to use. So most of the properties depend on those enums. For example, like here, when we select what style the badge should be, there are either some templates like based from design, such as light inverted or neutral or light. But we also have one of those. Usually we have a custom one that you can override whatever you want, in case as a client you want to really customize it but still use the component. On the right side is not so much visible here probably, but you might see how it changes. But when we for example, one of those enum cases takes some basic parameters, but there are also some default values, such as inverted here. So if we delete it, we still get some default style. For example, if we delete the icon, there will be no icon. And what is not shown here, but if we would just put there an empty string, there will be nothing. It will be empty view, which takes no space. So that could be reused in this way. And now some talk from the implementation, from the hassles that we had when we did it. We started at the time when there was Swift version 2 probably, and some of those components gave us a lot of pain, obviously. So the last thing you want to hear is that something crashes under 13.7 something under certain circumstances, but only on the iPad, for example. So many of those components are black boxes, which sometimes contain full of kind of support code. And I would like to show you some of those approaches. First, just a short recap of the phase, how even before we start implementing the design system. It usually starts with some design, and if you are lucky, your designers will provide you a design in such a tool that also supports something which is similar to declarative frameworks that we use as coders, which is a case for Figma, which not only supports text, for example, which is a basic thing, but it also supports components, reusing of components together, and also it supports variants. So even the designers themselves have variants such as is critical something, or does it have buttons or not. And in the API that we code, we try to follow that principle. We try to use the same names so that when you check the Figma, you will have a mental mapping between the code and Figma quickly. So similar properties are used, same names, so that in the SwiftUI you would have exactly the same result at the end, which obviously results in a lot of combinations that even designers usually do not see beforehand. And we have to deal with them as coders. So one thing that what we do in order to manage all those combinations, because it's a huge matrix if you have a number of parameters and combine it with others, we heavily depend on snapshot testing, which has been already mentioned here, where a snapshot from the previous version, a screenshot kind of the app, is compared to the other one, and we can see the difference if anything goes wrong, and we exactly see where it went wrong. And in order to provide a customization for those combinations so that the client can use it even for his specific purposes, we have kind of two ways how to provide this. So that normally, if you take the component from the design system, it will be very strict, kind of. It's what designers wanted you to use. But still, we have those two customizations. One is that we provide an enumeration case called custom, which contains all the other properties that normally would be driven by fixed templates. The other way is that we provide some injection points where a caller can use his own custom SwiftUI view whenever at those points, but could be any number of those contents. A typical one is that there is some card, and in the middle of that card, we want caller to be able to do anything he wants. But we provide the nice wrapping, which follows what designers wanted. So these are the two ways to customize it. And yeah, now I will follow with specific examples. We see, based on the time, of some of those gotchas and things that are maybe not so straightforward in SwiftUI. First of them, I would mention the text field, which is already a difficult component on its own because it's input from the user. There is a keyboard involved, a lot of scenarios in iPad. You can have overlaying models on top of each other with some animations. So that's the thing that is kind of tricky to do correctly, and especially in the SwiftUI, which doesn't still have correctly implemented some of those parts. And I wouldn't talk about the keyboard avoidance, which is a topic on its own, but even, for example, doing a secure field to provide a password field for a user could be tricky. It's available in the SwiftUI, yes, but does it look like the UI Kit one? No, it's kind of stripped down version of it, so it doesn't have such a good UX. There are a lot of things missing. For example, you don't see the last letter you write, for example, but there are many things like that. So what we needed to do is to have a SwiftUI component on the outside as a black box, but still in some situations, which is that the field is of type password, to reuse the UIKit version, which we know is safe and secure and tested and works properly. So this is one way how to do those things. To use the UI view representable protocol, optionally with coordinator if it is input component based, and mix the UIKit component inside your SwiftUI component. Nobody will know because that's just the internal implementation detail. and you can do it freely, so it's not all or nothing. So this is a nice way to fix those problems as you go and realize that there are some issues with it and you don't want to completely go the UIKit way. You can do it this way. And now it will be a code example of this component and how to approach it. So we have some component called input field, which is representing the text field. And in the demo, we see that one of those is the secure field, which hides the user input and allows you to see it and switch. All the other ones are just basic ones. But from the outside, it is still a single component from the design system perspective. It's just some switch that tells you if it's secure or not. And in that path of code, we just say that in a normal one, we use a text field for all those normal ones. But for the secure field, we will use our wrapper. And this wrapper, which itself is a SwiftUI component, but it's defined as a UI view representable implementing this protocol. And all you need to provide is give it whatever you want to create from the UIKit world, and also say what you want to do when it's been updated from the SwiftUI part. Optionally, also implementing the original delegate of that so that you can catch the delegate methods for which the coordinator is used for this protocol. And if you do that, you have a fully working SwiftUI component, which underneath uses the tested and bulletproof UIKit version. So that's one way to fix those issues, to just fall back to UIKit when you really don't have time to deal with it. No shame. The other one, the other component where I would like to show you the combination of mostly the preference key as a powerful tool in SwiftUI, where the geometry reader is used because it has to be in this situation. But again, as has been mentioned, I'm also heavily recommending our developers to avoid the geometry reader if you really don't know exactly what you are doing. But as it has been mentioned, it is pretty safe in the use of either background or overlay or this specific scenario that I will show you. The point is that on the right side, I don't know how well you see, it's a component which is similar to segmented control in the iOS. So it serves as switching the tabs. And one of them is always highlighted. Each of them can have a different style, so they do not have to necessarily be the same color, which will be visible in the animation, hopefully. So let's see what we have here. So the whole component, the outer one, is called tabs. And even I can't see it, so I'll just tell you that the help tells you that you have to use the tabs with a binding to the selected index, and then you can put as a view builder content any number of tabs, maybe even using for each, that you need. So this is avoiding that normally this component would have huge API with full of combination of parameters telling which tabs are there and which styles are there. So this is one way where you can have parent and child components, and you would kind of use the feature in SwiftUI that normally, to create something easy, SwiftUI is done in a mechanism that the parent always provides information for the child. That works in 90% of cases, and that's why it's easy to use. But in order to achieve some flexibility from the UIKit world, there is also a way to bubble up the information from the children to the parent, and the parent who would gather all this information and do anything he wants with them. And that's exactly this case, where we specify this component and we say what kind of tabs we want to have there, but the parent component called tabs will handle all the switching, the selected and index, animations, and so on. So this is just, now I can see it. You can't, but I can finally. So on the right side, we have a preview of those tabs with various layouts. We support multi-line and maybe not, that you define that you want only one line and you decide if the tabs should take the same size or not. Each of them could have different style. And the implementation of that, as you would see, is different from the UI kit, where we usually had to calculate everything manually in the imperative way, where you would measure with some font how wide some cell is, and then you would use this variable somewhere else. Here you will see that we will not count anything. We will let the SwiftUI system to do all that heavy calculations for us automatically if we follow the layouting system that SwiftUI provides us. Here you can just see, maybe, I don't even know if you see the highlighting of those tabs, probably even not. But I just wanted to mention that the animations are baked in the component. You can't screw them by animating them from the outside. So those components have their own animations. Whenever you switch for example, in this component, if we switch the selected index, it will animate whether we will switch it from the outside or internally by a touch event. And now to the implementation itself. So this is the parent component, but we will check the subcomponent that contains of. And the component called tab is just it is basically just a text which has some sufficient padding, and we use that to drive the parent component. So we will decide how the tab should be sized, not necessarily how it should look like. And we would feed the array of those values in the same order as they were defined to an array of those preferences. And what we tell to the parent, who will catch this information, is just what the label is, what the content of the text is, what style we want to have for this tab, and most importantly, this is the whole why we do that, the bounds of that component. And that's the power, that we let the SwiftUI just reuse whatever it thinks this subcomponent should be sized, and now we will use it in the parent component. How? I'm not sure. I will try if I can resume wherever I was, because it should be probably here. So yeah, we use a modifier called background preference value, which is acting as a background, but selecting the preference key that we want to gather. And what we do before that is that, oh damn, sorry for that. Hopefully. So this modifier, we tell it which key we want to listen to from all those childs, which are the childs that the caller will use. And we will render those tabs in a simple stack, which is this line. And based on that, driven by that, we have the whole content of this component. We have the size. This is what calculates the overall size for us. So we can already apply some background graphics to that, but we don't actually render it at this stage. We only use it to measure the overall size for us. So that, because if we would just use geometry reader on the normal hierarchical level, it would grow infinitely to both directions. That's not what we want. We want this component to be, as you see on the top right corner, if it is small, let it be small. So that's why we only use it for driving the size. We don't even render it. But later then, we use this background preference value with the combination of geometry reader, because it is here necessary to get the preference key bounds to be obtained. We wouldn't normally use it. We don't calculate anything using that manually. And then we just render all those tabs now for the real. So in this code for the tabs, for each of those tabs, we render the tab based on whether it is selected or not, based on its style that we obtained from child, and so on. So that was the main point of that tabs, that you don't need to be limited by the default way how SwiftUI flows down the data. You can also use it for doing much more dynamic components that take subcomponents and drive some logic based on them. And another example would be some more complex component. Let's say in our design system, we have probably the most robust of them is the itinerary component, which shows the user his whole trip. But it's even difficult for a user to understand it, let alone for anybody else. And in order for all the teams, like QAs, product managers, developers, to kind of know what we are talking about, it's even more important to slice down that component to reusable parts with some name, ideally having some same prefix. And this is the example how we slice some components to be able to, ideally even in the same manner that designers give it to us in Figma, which mostly doesn't happen because they could just draw it like on a blank canvas using custom frames. But if that even matches, even better, that the structure, there should be some structure so that you know how to start. Because if you would just implement this whole thing from the top, it will be a headache. So for this component, which is driven by some hierarchical model of data, I really recommend to slice it down and start from the smallest pieces, not from the top one, but from the smallest pieces. And when you know that the small piece, such as one of those rows, is fine, it works under all circumstances, multi-line or those edge cases, then move on to the other one. Also, some of those animations are even better to do on when you gather those subcomponents and then use it as a background or some overlay with a blending mode in SwiftUI. You don't necessarily have to follow the stack as is. You can use some tricks with blending modes to hide some animation artifacts. And for this component, again, some small demo. So the whole component, the itinerary itself, is huge. But the only thing you need to provide to is some kind of list of so-called sectors. It's just driven by that. They have their own arrays of data underneath. But you can use this component anywhere in the app, anywhere. You just need to follow that you give it what it wants, which is the bunch of data, and it will work anywhere. As you see, this is still one component, but it's made of something called itinerary sector, which again I will be repeating this few times. It has a bunch of layers. Again, it consists of some heading and another for each of another reusable component, which you do not necessarily need to use here. You can use it anywhere else. That's the beauty of composition in SwiftUI, that really, if you do those components this way, you can put them anywhere. They don't depend on any domain logic. They don't depend on any combined frameworks, things like that. As long as you follow the rule to use the simplest API possible for that component, you will have nicely reusable component, and anyone can use it because the component will only want what it needs to be correctly drawn and behaving. So again, this is something called segment group. Again, we can see by highlighting the code if, for example, for example, if there is a new developer who could have trouble with navigating all those new components, it's always easier to stack those things in the right order, so that when you highlight it, you follow from top to bottom, even visually. So again, we are digging deeper and deeper, and on this component, again, we have some parts which it consists of. Some of them are driven by flags to provide an animation of expanding and collapsing state, for example, which you can bubble up again to the parent, so that even a client who uses this component knows how to react to that animation. And now we are at the point of the smallest component that we had in the slicing. So this would be example of such small component where you see that you can just give it a time, date, city, code, whatever, and it's rendered correctly. And you know that you can use it anywhere you want without any dependencies. Let me see if there is something more on this video. Probably not. So on this component, I wanted to show that if you do a huge screen or some complicated component, it's always better to slice it down to something even potentially reusable everywhere else, even though you think that it's just used on this screen. There is a high chance that somebody will tell you, we even need it for some other. So why not? So always it's best if each component fits your Xcode one page, even better, into a single body with some helper functions, so that everybody can navigate quickly on that component and highlights what sections it consists of, replace it with other components and so on, rather than doing a huge SwiftUI code with where it's hard to find things and find bugs and fix it. Some takeaways from this talk, which is nearing its end because we are a little bit late. And one first of them is that having any design system greatly improves the reusability and consistency of the whole app, of the whole even product, because you can have the product for which spans through desktop, mobile apps, and so on. Even though it's not necessarily needed, it's nice that this product has the same branding, same style, visuals on each of those platforms, so that users recognize it immediately. The other one is that don't worry to, and don't be shy to just use the UI kit in the SwiftUI anyway. It's possible. There are some caveats, as already been mentioned in the previous talk, but it's definitely possible. We have good results with that to slowly fill up our SwiftUI library. So again, it's not all or nothing. You can mix it together. And the next one is that the Orbit design system, the one we have, is available for use in your project. So you can, if you want to start with SwiftUI or just try to learn how it works, this could be a good way to use it in a very easy way, so that you will skip those initial things that you might be needing to solve manually by just reusing whatever we already prepared. And the last one is that it's open to contribution. It's open source project, so if you want to maybe have some ammunition to your iOS CV or whatever, you can jump in and see what issues we have there, what features we are missing, and feel free to visit the GitHub page and check our code. So that's from my side. Now, if you have any questions.
So my question is, how much of the kiwi.com app is converted to SwiftUI?
You mean, for example, how many components?
No. Oh. How many screens or
the app. Yeah, from the kiwi.com app, yes. Hard to tell. I would say from all those, we have a bunch of screens that nobody even knows about. They are like edge case screens. But from the screens that normal user usually visits through his happy flow, I would say that maybe we are getting to half. Any other?
So if I get it correctly, like designer makes some design, then developer implement this kind of design, and then you say like, okay, this is cool, so maybe we can add it to this Orbit package, and then, or this is like the way how it works?
Yeah. The question was about the workflow, how do we know what to implement from the designers, right? At what time? In our company, it is exactly like this, that we are catching up with the designs, basically. We jumped in a little bit later on the mobile development, so But as soon as we will have all the components correctly implemented, along with all those iOS edge cases, as we spoke, then it will be much faster, and we will be mostly one-to-one with, I would say, few weeks delay from what designers have or what the desktop version has. Yep.
So if I understand correctly, components such as like tabs has predefined animations, right? I have two questions. First is that if I want to change the animations for spring or for something else or add the delay, how can I do it? And the second question is, wouldn't it be easier if I don't have predefined animation and just initiate the components first and then add the animation there?
Mm-hmm. So the question was about the flexibility of animations in the design system components, kind of. And so I will try to answer it one by one. The first one is that the designers also should be responsible for animations. We help them with that, but the animation is a solid part of that component. So we don't want client as similar way as we don't want them to use different colors in some ways most of the time. We don't also want them to do some things much more faster or slower. But again, as I've said about some injection points for customization, it could be possible when we see that it has some value to provide a custom animation. That's possibility, obviously, in SwiftUI anywhere, not only in some design systems. We can apply anything as a modifier somewhere in the parent. And so if I missed some of those, please tell again.
The second question was like, if it would be better like to have auto animation and just add it later, because we can initiate the tab
Yes.
and then after that like animations.
Yeah, it's could be a good idea for the customization point, the optional one, but by default we want caller to get exactly the animation we prepared. The same way as we prepared all the other things that are sticky on that component. And there are only really few customization points which are kind of approved so that it doesn't break the original purpose of that component.
I would like to ask, you showed that you have some component which was like a itinerary segment. For example, is this built into orbit library or is this?
Yes. It doesn't look like. It's normally it's so huge that it usually wouldn't be a part of any design system as we think about it. Usually you will think about buttons and some small ones. But this one, for the purpose of unifying our app, we also wanted the callers to get a component which also solves them something that's very frequently used in travel-like apps, which is itinerary. So that's why this is also treated as a component. It's a kind of work in progress. It's not directly in the GitHub yet, as I have shown. But yeah, so this is, again, also a component, huge one, yes, but it's potentially interesting for any travel-like application to have it available, to not do it themselves.
Yeah, and do you have some practice? How do you handle some special components that are not part of the orbit library but part of the application?
So the question was mostly about the ratio or kind of splitting when we have an app and we use orbit or these design system components versus some custom components that are also in the app, right? It would very depend on the company and so on. In our case, we try to always tell designers that whatever they are doing is probably already some existing orbit component, so that we don't have to implement it again, just a little bit differently. And also, as with any other things, if you have 30 components, everybody can remember them. It's easy to work with them. If we would have 200 of them, everybody will be lost. So we try to keep that to minimum by always asking, is it necessary to do a custom design on this screen? Couldn't we just reuse the orbit component that we already have? And sometimes we win, sometimes not. But yeah, that's a good question.
I have a question. Does the design system also contain logic? For example, the text field has some validations. Do
Good question. The question was about if the validation and some kind of domain logic is already included in some components. And the answer is no, not at all. All those components are completely dumb, so that any application can use them without any dependencies. Maybe just, obviously, if we have input field, then you can provide placeholder in case the text is empty. But this is not a validation, right? It's something a little bit similar to that. But no, we don't. Everything is done so that you can reuse it everywhere, and you don't have to learn somebody else's logic. So this is completely out of that. Every component has a as much small API as possible. So we usually tell it what you want to display for a text, icon, whatever else, and everything else is default. And you will just build on top of that.
And is it because of the open source? Like you want to pop up open source so anybody can use it, but I can imagine that inside the company you are using it in the same way.
Yeah, but usually what you would do is that you would just assemble those components into some UI, such as screen or some part, and you would write the logic in some view model or something else, which will provide the parameters directly to that component. So there is, I don't see, we don't have anything like that inside those components. So the component responsibility is only draw itself correctly, behave correctly, animate correctly, provide some binding data out correctly, and nothing else.
I wonder if the accessibility features, let's say the change of layout for large content is also a responsibility of client.
Good question. It was a question about if or how the accessibility works in our design in our implementation of the design system. This is currently heavily work in progress for us. We mostly support just a correct combination of accessibility types, so that if you have a button, it correctly recognizes as a button and reads the label for the blind users. But if it's maybe some specific example.
Like large fonts, when you increase the font size,
yeah. So
usually it's recommended to change the layout a bit, so it's more visible, like two labels next to each other, so you should switch it on to...
Yes. So none of our component has this dynamic layout so that it would switch in different environment or under different circumstances, such as dynamic font sizes. Sadly, no. We don't even now correctly support dynamic sizes yet, so that's our next milestone. The dark mode would be the next one, and this is like a cherry on the cake. If we are there, then we can like slap us.
Is it planned to be like a responsibility of the client or of the library to implement those stuff?
Well, as a client, you can provide accessibility identifiers, either to that custom content that you inject, so that's your responsibility, or to any wrapper. And if our component is a wrapper, it usually provides parameters for some parts of that. So that's already there mostly.